Hi everyone, I'm Gangfeng, and with me is Ashir. So today we are very excited to share how at Intuit Credit Karma we use Airflow DagFactory to tackle challenges and data quality pipeline scalability. Our talk today primarily focus on how we moved from repetitive and hard to maintain code to a dynamic and a no-code based approach for Airflow DAG generations.
Show of hands, who here doesn't like data quality, hates data quality, thinks it's very repetitive? Yeah, I mean, at least I do.
All right, before we dive into the technical side, let me introduce Intuit Credit Karma. So our mission is actually to champion financial progress for over 140 million members. And our vision is to create a self-driving platform that would allow our members to make better and smarter financial decisions. And then the next slide, we also like to talk about our team. So we are from the Credit Karma credit ecosystem team. And essentially our team is the front gate for all member financial data. We handle data ingestions from all our partners as well as data providers, both through API and batch. And this data serve as a single source of truth for all member financial profiles. And also we manage over 20 microservices that keep the data accurate, timely as well, and ready for our downstream consumers. So about us.
So I'm Ashir, working as a senior data engineer, Go Trojans, graduated from USC. Primarily been working on data quality recently, but I also work on data platform, infrastructure, GCP, data migrations. Even though I hate it, I guess I had to. And then, yeah, confirm.
I'm a BI engineer. I'm from U of I. Anyone from U of I here? Oh, nice. And then I'm primarily working with scalable data pipelines as well as self-serve platforms, and then also some dashboard optimization and data quality assurance. So let's get started. So here, this is what we're going to cover today. First, we're going to talk about the challenges we faced in our prior data quality framework. And then next, we're going to dive deeper with more details in our solution, focusing on no-code-based approach for the DAG generation. And then we will quickly walk you through how does it look like in practice. And next, we're also going to talk about what we have achieved, what's the impact. And finally, we're going to wrap this session with Q&A. Okay, so as I just mentioned, the credit eco team is a front gate for the financial data at Credit Karma. So our data platform operates at a massive scale. We process over 1 billion records every day. So at this level, the scale and data quality are equally important. So our data must be complete, timely, and accurate, because data so that we can make sure the data decisions at Credit Karma are using these correct signals.
Also adding, we are at the heart of Credit Karma data ingestion, so it becomes even more important just because literally all of the company is dependent on our data.
Yeah, I totally agree. So now when it comes to data quality, I believe everyone would agree that it is important, but how we implement the checks always be chaotic. This graph is pretty much sums it up. Every team, everyone tries to build one true standard, but before long, we always end up with even more competing standards. So this is exactly what we were facing, multiple teams with slightly different implementations for the same type of data quality checks. And here is our main point looked like initially. So first of all, we have lots of almost identical DAGs that actually makes the system kind of messy and very difficult to maintain, to manage. And second is more around like copy paste problems. Like we typically just copy the existing DAGs and to create a new DAG. So this would actually introduce human errors. And another one is high maintenance. Like one small update would require us to modify multiple files. And finally, the bottleneck, like our engineers will be focusing on spending time to developing these DAGs rather than actually to focus on something like more meaningful, like innovation. So all these issues cannot point to like one big question: how could we scale those data quality checks without adding like additional manual work as well as code duplications? And with that, I will hand over to Ashir. He's going to walk you through like other challenges we faced as well as how we tackle those problems with a more innovative way.
All right. So our previous architecture. So we had data quality before I joined, or like even before that, but it was still running in Scala microservices using Finagle, Cats effect, Akka streaming, other very Scala-specific things. And like if you're not using Spark or other frameworks with Scala, it's not very optimized. It's not big data optimized. Missing integrations. So we didn't have email or PagerDuty integrations, so it was harder to get better responses on alerts. Since it was Scala-based, we needed there was a high barrier to entry. Like many data engineers, we might not be working with Scala, as well as like analysts, BIs, other people. Lack of data quality alerts as well. So since the platform itself was a bit complex, not everyone would go and add something very easily. And then we lacked some kind of data quality metrics. Since there were lack of alerts, we also lacked of data quality metrics. Just summarizes or depicts how Scala can be with all the messy functions, or if not messy, at least a bit hard to understand functions that we have. All right, so the solution, like what we are doing in this case. So just in very layman terms, anyone now, if as soon as they want to add a data quality check, they are like, hey, I want to do a null check on this attribute. They'll just go to a UI, fill some things up there, and it will automatically trigger a GitHub PR executor that creates a GitHub PR into our DAGs repo. And then obviously the CI/CD and everything that goes in there. So makes it easy. And we hide the complexity. No more Scala. No more even Python, as I'll go through in just a bit. We are using YAML now, and we are able to manage more governance. So we are for all the data quality. We are also able to store the results of data quality, how and when an alert fired, what was the reason, all of that into a BigQuery table or like any data warehouse table, so that it's easy to manage / go back to your services and see which services are messy or like which alerts are bad or good, all of that stuff. This gives a sample of how data quality workflow architecture looks like. Last one was just like basic, but we have a UI, which I'll go through in a bit. From the UI, we fill up a whole bunch of things. That UI is not AI. The results of that UI is not AI generated. It's manually written by me in either a text or YAML format. And then that generates a YAML file that contains your actual alert. The way we do this is with YAML, there is something called DagFactory by Astronomer, but it's an open source thing. And DagFactory is able to parse everything in your YAML and create a DAG for you, proper DAG, like Airflow DAG. So YAML generated creates a GitHub PR. There will be reviews, there will be Circle CI validations or other CI validations that you can have. DAG will, as soon as that merges, it will create a Airflow DAG that is running in Cloud Composer for us as of now. This is a sample. It looks like this. Obviously, there are way more steps, but this is just how a YAML would look like. In our case, you just give a whole bunch of things like your basic Airflow Airflow parameters, and then you start with your tasks and start giving it more tasks, whatever you have. So Python glue code, if you see, this is all the Python that we have for any of the DAG. No more writing 80 lines, 100 lines of Python or doing anything. So basically, if you see config directory, this is, so first of all, we are using DagFactory as it's in line 4, and it's able to load YAML DAGs. And it's able to load YAML DAGs from all the, from that folder, specific folder, which is in config directory, and then it works like a magic. It will parse all the files within that. So like you have hundreds, thousands, it will parse all the files in that and create one DAG per each file for you. I think there are other ways of generating tasks, dynamically generating tasks, but we felt that generating DAGs made way more sense for us for each our different alert. This is a sample, or not sample, this is like how we actually have implemented data quality DAG. All of these, they end up becoming a different steps in our YAML file. So we'll try and compare and get all the metrics to write to a BigQuery table. So you run your quality check, write to a BigQuery table. Next step, we compare it with the threshold. So in the form, in the UI, we also mention a threshold. So for example, you don't want your alert to run as like when metrics is just slightly breached. You want to run when the metrics is breached by a lot. You could do that using a threshold. Or like you want your data completeness to be over 99%. So you could give 99, 99.5, 99.99, all of that stuff. And it will only trigger when the threshold is breached. After that, we'll figure out if an alert is needed or not. So it will compare the metric, which we calculated in step 1 with the threshold that we have in our YAML. That will be a user inputted field, and it will decide if it should trigger or not. So as soon as it triggers, standard flow goes through PagerDuty Slack, which we lagged. We had Slack before, but we lagged PagerDuty. So it goes through PagerDuty, and then if the flow succeeds and we don't need an alert, the DAG just exits without doing all of that. End result. This is a sample of how our production DAG looks like. In this case, everything passed, and an alert was sent to Slack or PagerDuty. But if an alert is not needed after second step or after third step, it would just stop the DAG and exit the DAG in a successful manner. This is how a sample Slack alert looks like. We are able to give message, runbook, follow this, that, all of that stuff. Not too much detail, as well as the metric, like what was the metric that made it fire. You could absolutely have 99.9 and have it fire instead of 1. So it depends on use case. Great. So let's do a demo. So this is how our sort of UI looks like. It is company specific, but I created a sandbox for us. You could give n number of fields, whatever you wanted. In this case, we gave it whatever we wanted to store in our metrics table, so that it's easy to go back and check what was the miss, which table had a miss, all of that stuff. And you can give it run schedule when you want it to run the DAG. Some extra metadata around if you want to do alerting, all of that stuff. Threshold, so you could give 0, you could give 99, And you can also specify the operator you want, like should the metric be greater than 99? Should it be greater than 1? Should it be less than 99? And that's when the alert should trigger. And if you want, you can give a custom SQL. And let's do a run. So it will do its magic, not designed by me, but some great people in our company. And it has GitHub PR executor underneath. So let's go here. And this was opened just now. At this point, we are creating two files. One is, let's see if I can zoom in a bit. So YAML file with some additional standard metadata, alert description, the tasks I want to run. So calculate metric, write to table, compare with threshold, alerting or not, all of the things that we just discussed, but everything is written in YAML instead of Python code. Obviously, if you want, you could still have custom Python classes called here, which is what we have done here, because for our use case, it was like we could use same Python class in different DAGs. And then the SQL file, or like any kind of file you want to run for your DAG. Summarizing and impact of this. So we were able to reduce our time to deploy for the DAG. So with the previous architecture, it was you create a PR in Scala microservice, have your team review it, send it to the owner of that service. They'll review which, whenever multiple teams are involved, you have way more time that it will take. And then like deployment. So now it's all our team. You can specify different owner groups. All of that is possible in GitHub. But with this, we were able to get it down from days, at least like 3 days, to less than 2 hours. Right now, it's just you clicking a bunch of fields, post it in your team channel. They'll approve. And since it's all UI generated, it's not someone writing custom things, it becomes way easier for a reviewer to see this and be like, hey, yeah, I don't care that much. Or I'm like, people might be like, yeah, fine, it's all generated, so it should be good enough. So reduction of that by 95%. Since we added PagerDuty integration, we were able to get faster response time. Before it would just post on Slack. Now we have PagerDuty. So like, I think most of us agree that we might not be checking Slack after 6 p.m. Error elimination might be more like 99%, but I wanted to put 100% just because things are automated, but users can still fat finger on a UI. So that can happen, but still pretty good compared to what it was before. And it is self-service now. It's just a UI, as we just saw. And governance. So since we are writing the results to a table, we can go back 6 months later to that table and see how many alerts fired. Or holistically for a whole year, we could be like, hey, how many alerts has this product like fired for in the last year? And like, do we need to take more actions? What do we need to do around that product? With everything, challenges come up. So for us, it was trying to figure out what kind of like how simple it should be, as well as like simple for the developer, which was in this case me, and simple for the user, who are all the users using this UI, to be like, hey, does this make sense? Does it not make sense? Still work in progress. I'm still trying to make sure the things in UI are what's needed, and not like, yeah, you just put something there. Outgrowing our infrastructure. So even though we are on Composer, whenever you are creating your instance, you can select a small, medium, large instance. In this case, since this started as a POC, I was like, let's start with a small instance. And then we very quickly outgrew this because of good user adoption. So then we had to scale. So maybe like it is a trade-off, but I think a good trade-off that more people are using this. Versioning. So before, if you had to add stuff, like it was a bit harder task. But now you have YAML, where things are easy to read, easy to add. And if you have custom Python class, that's also a possibility. And then driving user adoption, I think it's an ongoing problem, but I think everyone faces that, or even when you are using open source, that you might lack something on documentation. I do that too. I'm like, yeah, I don't understand this document, or the user who are using this product might not be very clear with documentation. So it's a continuous journey for me too. With that, yeah, we wrap up.